All right, let's talk about what happens when two of the most powerful technologies on the planet, AI and quantum computing, start to converge. Now, for anyone in business, this isn't science fiction anymore. It is a strategic reality that's taking shape right now. So we've boiled down all the key research into a clear, no-nonsense briefing for you.
So, here's how we're going to break it down. First, we'll talk about the classical wall, basically where today's computers just completely hit their limit. Then, we'll dive into the quantum hypothesis, the big idea that's supposed to solve all that. After that, though, we need a harsh reality check on where this tech actually is today. And that leads to a really cool twist, the quantum-inspired advantage. And then, we'll wrap it all up with what you really need, your quantum-ready playbook, a clear strategy you can actually use.
Okay, first up, the classical wall. We're talking about the specific, high-value problems where even our beefiest supercomputers just throw their hands up and quit. And this isn't just about needing a faster processor. We're talking about a fundamental mathematical barrier they just can't cross. Which of course leads to the big question. Why? Right? Why can't we just build bigger, faster machines and power through these challenges? What is it about certain problems that makes them totally impossible for the computers that, run our entire world? Well, the answer is a wild concept called combinatorial explosion. Think about it like this. You're a marketer, and you have to split your budget between, say, 5 ad campaigns. Easy enough. But what if you have hundreds of campaigns across dozens of channels? The number of possible ways to allocate that budget doesn't just get big, it grows exponentially. We're literally talking about more possibilities than atoms in the known universe. No computer can check them all.
And here's the kicker for business. It means we're not really solving these problems. We can't. We're using shortcuts and clever math to find a good enough answer. It means there is money, real value being left on the table because our computers physically cannot explore the entire landscape of possibilities to find the single best answer.
And that is the perfect setup for Section 2, the quantum hypothesis. See, if classical computers hit a wall, you don't try to punch through it. You find a new kind of computer that plays by totally different rules. This is where we start to see how these impossible business problems could be solved with a brand new quantum toolkit.
So the whole idea is that quantum computers aren't just a faster version of your laptop. They work on completely mind-bending principles, like superposition, which allows them to explore a huge number of possibilities all at the same time. Instead of checking every single option one by one, it's like they can feel the entire landscape of solutions at once to find the absolute lowest point, the optimal answer. And this table just maps it out perfectly. Take marketing mix modeling, that crazy budget problem we talked about. Well, there are quantum algorithms like QAOA or quantum annealing designed specifically for that. Or what about customer segmentation, trying to find patterns in data with thousands of dimensions? Quantum machine learning offers a whole new way to see those connections. Even real-time bidding for ads, which is all about speed, could use quantum optimization to find the perfect bid in a fraction of a second. Okay. If the theory is so perfect and the mapping is so clear, why isn't every Fortune 500 company running on quantum computers? Well, this brings us to a really important harsh reality check, because the gap between the theory on a whiteboard and a real, working machine is massive. And you don't have to take my word for it. This quote from the Boston Consulting Group just this year really says it all. As of right now, there is no tangible advantage in using a quantum computer for any commercial application, period. Despite all the hype you read, we are still very, very early in the game. You see, we're living in what everyone calls the NISQ era. That stands for Noisy Intermediate Scale Quantum. Noisy means the basic components, the qubits, are incredibly fragile. The slightest vibration or change in temperature can corrupt the calculation. Intermediate scale means we have like a few hundred of them, when we really need millions to solve those big business problems. And because they're so noisy, our programs have to be super short, what they call shallow circuits, before the errors just pile up and give you garbage. Let me give you a quick story that just perfectly illustrates this reality check. For a while, there was this one algorithm that was the absolute poster child for quantum machine learning. It was designed to build incredibly fast recommendation engines. A huge problem for companies like Netflix or Amazon. And the promise here wasn't just, a little bit faster. It was for an exponential speedup. We're talking about something that could solve a problem in minutes that would take the best classical computers literally centuries to crack. This was supposed to be the slam dunk case for quantum advantage. And then the whole story flipped. In 2018, an 18-year-old undergrad, Ewan Tang,
figured out how to get the exact same exponential speedup on a regular classical computer. She essentially dequantized the problem. It turned out the quantum advantage everyone was so excited about wasn't really there.
But this is where the story gets really interesting. This failure leads us to the most surprising and, frankly, the most valuable part of this whole field right now, the quantum-inspired advantage. It turns out the biggest ROI from quantum research today isn't coming from quantum computers at all.
So what dequantization actually means is that by studying the math behind the quantum algorithm, researchers discovered a brand new, way better classical algorithm. Here's the lesson. Classical computing isn't standing still. The very act of trying to build quantum solutions is teaching us how to make our existing computers better, faster, and smarter right now.
So, after all that, the hype, the reality, the surprising twists, what are you supposed to do? That brings us to the final, most important section, your quantum-ready playbook. This is a simple, pragmatic strategy for any business trying to figure this all out.
Look, every business has two clocks ticking right now. The first is the opportunity clock. That's your offense. It asks, when will quantum help me? Most analysts think that'll be a slow rollout, with real broad advantage starting to show up around 2030. But the second clock, the threat clock, that's your defense, and it asks, when will quantum break me? And this one has a hard deadline. The consensus is that by 2029, a quantum computer will be able to crack the encryption that protects basically everything online.
And that threat is happening right now. It's a strategy called Harvest Now, Decrypt Later. It means bad actors are already stealing and hoarding huge amounts of encrypted data today. They can't read it yet, but they're just sitting on it, waiting for the day they can get their hands on a quantum computer powerful enough to break it all open. This isn't a future IT problem, it's an immediate data liability.
So here's your playbook. It's 3 simple tiers. Tier 1 is for today. Start deploying these quantum-inspired algorithms on the computers you already have. Get that immediate ROI. Tier 2, for the next year or two. Launch a small, focused proof of concept on a hybrid system. The goal isn't to solve a billion-dollar problem, it's to start building skills internally. And Tier 3, over the next 3 to 5 years, align with your security team. They're going to have to migrate to post-quantum cryptography. Use that mandatory project as the perfect excuse to build a deep, strategic talent pool for the entire company.
And that really just leaves one final thought. This isn't about perfectly predicting the day quantum advantage arrives. It's about being ready when it does. Because the biggest barrier won't be the technology. It's going to be the tiny number of people who know how to use it. So the only question that really matters is, your competitors are already building their skills? Are you?